Welcome to my channel. In today's class, we are going to look at quadratic graph. We already know that a quadratic equation is of the nature as squared plus bs plus c equal to 0, such that a not equal to 0. So in this class today, we are going to look at how we can be able to plot a graph of a quadratic equation and get our solution from the graph. So the first thing we are going to look at is the kind of graph we expect to get in a quadratic equation. The first type of graph we expect to get is a real and distinct root. Okay, a real and distinct root graph will look like this, or will look like this. Okay, so here is your y and s axis. So you are going to have here as your solution, so call it x1 and s2. So the value of your x at x1 and the value of your s at s2 will give you your answer. Okay, the same thing we have here. So here is our s1, here is our s2, here is your y-axis, and here is your x-axis. Okay, so where the curve cuts the s-axis, the value of x there will give you your root, or we can also call it solution. The second type of question the second type of root we expect to get is a real and equal root. A real and equal root. A real and equal root will look in this form. You might have something of this nature. Okay, so this is your y-axis, this is your s-axis, or you might have something of this nature. So don't mind my curve. So of course, here is our origin. So this is your y and this is your minus s-axis. Okay, so we can have a curve of this nature on real and equal roots. Now, how are we going to get our solution if we have a graph of this nature? The value of x as the point of contact, s1 equals to s2, s1 equals to x2, so s gives us x1 and what? x2. So here in real and equal roots, the two roots will be the same value. Okay, now the last one, which is number 3, when we have no roots. In secondary school, we say it does not have any root, but when we move a little bit advanced, we call it a complex root. Okay, we call it a complex root. So when do we have this complex root, or what we call no root, in secondary school? That is when you have your curve and it do not touch the s-axis. So this is your y, this is your s. So whenever you plot a quadratic curve and it's of this nature, or you have it like this, so this is your s-axis, this is your y-axis, or you have it in like this, that the curve do not touch the s-axis at any point, then we say it does not have any real root. Okay, so we can even put this no real root. So, but it has a complex root. Okay, now let's now get into the business of the day, which is how we can be able to plot our quadratic graph. So the first thing to do is to equate our problem to y. Now this step is not actually too necessary, because when the examiner wants you to plot a graph of a quadratic, they will not give you something like this to plot, because there's no way you can plot this on a Cartesian plane. Why? Because you have your x only as the variable, and in a Cartesian plane there is x and there is what? Y. So most times what we will be given to plot is going to be as squared plus bs plus c equals to y, or you can read it from y equal to as squared plus bs plus c. So this is what you will be given to plot, but when you are done plotting this, most times, in fact 90% of the time, is that the examiner will not ask you to use your graph to find the value of as squared plus bs plus c equal to 0. Okay, so the graph or the curve is this one. Okay, why the equation we are going to use the curve to solve is this. So you are going to see how it plays out. So when you have gotten the concept of this, the next thing now is range of values of s. Now in most exams you'll be given the range of values of s. Why are you given the range of values of s? Because we don't want you to plot this curve to infinity. We want you to have an exact value where the curve will start and end. We need you to have the range of x, because this range of s will help you to get the corresponding values of y that will help you to plot your graph. Okay, most times the range of values of s will be given to you, so you are going to use it to now construct what we call table of value. When you are done with construction of the table of values, the next thing to do is the scale. Okay, now what is scale, or what do we mean by scale? Scale is how you can be able to reduce the values you have in the table of values so that it can be contained in your graph. Remember, if all your points in the table of value is not contained in your graph, that means you do not use the right scale. Okay, so like range of values, sometimes also you might be given a scale. Okay, so we are going to solve a problem when some of all these things are not given to us, and when some of them are actually given to us. Then with your scale now, you have to go and label your graph. Okay, now what I mean by labeling your graph is going back to your graph, putting your point s and point y, writing all the values of your point s and point y, and using the scale to write the values on the x-axis and the values on the y-axis. So that's what I mean by labeling your graph. Okay, so one of our videos we did linear equations, simultaneous equation on graphical method. So what I mean by labeling your graph, like this graph here, you know, writing all these 1, 2, 3, 4 using your scale. That's what we use to get these values. So we'll put on these values. That's the next thing to do. So when you are done writing all those numbers on your graph, the next thing you need to do is to plot your points. Plot your points on the graph. Okay, now what do I mean by plotting your points on the graph? You have to go to the table of values, pick each value of s, the corresponding value of y, and locate those points on your Cartesian plane, which is your graph. So you have to do that for all the values of x in your range, okay, and the corresponding values of what? Y. So if your range is about 7 numbers, that means you are going to have about 7 points on your graph. If your range is about 8 numbers, that means you are going to have up to 8 points on your graph. Then when you have concluded with plotting your points on the graph, the next thing now is to use a curve to join the points. So join the points using a curve. Okay, using a curve. Now this is where that is the most challenging aspect of graphical method of solving quadratic equation. Okay, because some students find it difficult to draw a curve following a particular point. Okay, there are so many gadgets or equipment, even homemade equipment, that one can use as an assistant, such as flexible ruler. Some people use flexible ruler, while some people use a broomstick, while some people use a French curve. Okay, originally we make use of French curve, though you can also plot with a hand free. I plot with hand free a lot, so I'm going to use that in this video to plot a hand free graph. So after joining the point using the curve, now to find the solution, you find the value of s where the curve cuts the x-axis. That is the root of the equation. So what we are talking about is you have to find where the curve cuts the graph. So that point is the root of the equation. And what we mean by the value of s, or the values of s where the curve cut the s-axis, is in a diagram like this. So let's assume that this is your graph. So the value of s at this point, the value of s at this point, and at this point. Okay, so the two values of s here are the roots of your equation after you have plotted your graph. So if you also have this type, the two values of s at these two type, at these 2 points, they are your uh, root of the equation. Then if it's a real and equal root at this point, so you all you need to do is to say that the x is equals to this value twice, because both your s1 and your s2 are at this point. So if you also have this kind of graph, okay, most time nobody will give you this kind of graph because they know that there will not be any solution to it. This is what we call a no real root or a complex root. So we are going to solve example now and plot the graph and see how that goes, and see how to get the root of the equation using graphical method. Let's look at an example. In this example, you are given a graph to plot. You remember I told you that they will not give you a quadratic equation that is equal to 0 to plot. It will be equal to y, so that when you plot the curve, you can use the curve to now find your equation. So you can see that you are asked to draw the graph of y equals to 2s plus s minus 6. Now see the range of values like I told you before. So you are given the range in this question from -4 to 3, and you are also given the scale. So they say a scale of 2 cm to 1 unit on x-axis and 2 cm to 10 units on y-axis. Then require to use the curve to find the solution of the quadratic equation. So we have to start. If you check what we listed out last time, you will see that you will be asked to equate the equation to y and plot this. The range of x is given to us. If you check, the range of s is given to us as from -4 to 3. You use that range to consult the table of values to get your table of values. So when you get your table of values, we are supposed to from table of values to get our scale, but we are so lucky that the scales are given to us for s and y axis. So with that now, we use it and label our graph. So when you are done labeling your graph, you plot the point on the graphs. Join the point using a curve and find the value of s where the curve cuts the x-axis. That is the root of the equation. So we are going to start now. We are given the range already. Then we need to construct our table of values. Now, in your graph, you are supposed to make use of this place. In doing that, you're supposed to make use of this space. That's what this space is for, to write the name of your graph. So this is a graph of y equal to 2s squared plus s minus 6. We have our scale on x-axis. Our scale on x-axis is 2 cm to represent 1 unit, and on y-axis is 2 cm to represent 10 units. So you will come here and do your table of values. So table of values is a very simple thing to do. You draw your table. So let me write the equation again here. So here is x and here is y. So the range is from -4 less than equals to s less than equals to 3. So this range here simply means this: -4 less than equals to s less than equals to 3. So what that means is that I'm going to start from -4, -3, -2, -1, 0, 1, 2, and 3. Okay, so we need to find the corresponding values of y at each value of s. So now, what does that mean? It simply means that in this equation here, you replace s at each value of s, you replace the value of s with this value here. So in this point now, if I want to find the corresponding value of y, all I need to do is to take this -4 and replace it here and also replace it here. Okay, so I'm just going to show you how to do one of them, one or two, then I will fill it up. You can use your calculator if you're allowed to do so. If you're not allowed to do so, you can do it the way I'm going to show you now. So I can say 2 at s equals to -4. 2 into, in place of s, I have -4 square plus bracket -4 minus 6. So this will give me 2 times, this one is 16, because -4 square will give me 16. So 2 times 16 will give me 32. Plus times minus will give me -4 minus 6. So that will give us, so this will give you y. So that will give us 32 minus 4. That will give us 28. 28 minus 6. That will give us 22. So I'll have 22 here. So at s equal to -3, I'll do the same thing. So 2 into -3 square plus -3 minus 6, that will give you your y. So Minus 3 square is 9, times 2 will give me 18, plus times minus will give me minus 3 minus 6 equal to, what do I have? 18 minus 3 will give me 15, 15 minus 6 will give me 9. So I will have 9 here. So that's how you are going to use and fill up your table of value. Okay, if you have calculator, it's very simple. The way you have it here is the way you are going to press it in your calculator. You press 2, open bracket, press minus 4, close your bracket, put your square, plus open bracket, minus 4, close your bracket, minus 6, you press equal to, it will give you 22. So you write it. So when you are using calculator, it's a lot easier. So I'm going to fill it up now. So when you continue this process or using your calculator, you will be able to fill up this. Now remember, I said something initially, you need to know the value of each of these tiny lines, okay? Each of the tiny lines, you need to know the value. So for example, on SR6 now, we said that 2 cm represents 1 unit. So each tiny line is going to give us 1 over 10, which is 0.1. Okay, and on y-axis, we say that 2 cm represent 10 units. So each of the tiny lines, what I mean by tiny lines is all these small lines here. So each of them uh on the y-axis is going to give us 10 over 10. That will give us 1. So each tiny line in the y-axis is going to be 1. So if here is 2, then if here is 5 or 10, then the next one will be 11, 12, 13, 14, like that. Okay, so let's first plot this graph. So I'm using another graph now so that we can be able to see how we do this. This 2 cm to 1 to 10 units is actually much, is a lot. It will make us not to exhaust the space we have in our graph. But that notwithstanding, let's plot that graph. So I will label my graph. So I'm in the step of labeling graph now. So this is where we have done the table of value. We are done with the scale. So label your graph. So I will get my graph. So this is my graph. So I'm going to draw the line. I hope you are seeing the way I'm doing that. Your work have to be very neat. Okay, so I have ruled the axis. So here is a positive y-axis. Here is your negative y-axis. Here is your positive x-axis. And here is your negative x-axis. So here is your 0. So I'm going to use the scale. I'm going to use the scale given to us to label the graph. On x-axis, 2 cm to 1 unit. So every 2 cm will give me 1 unit. So here is 1, here is 2, here is 3, here is 4. So I have minus 1, minus 2, minus 3, minus 4. So I have labeled the x-axis. So the next place to label is the y-axis. They say 2 cm to 10 units. So here is going to be our 10, our 20, our 30. So down here, minus 10, minus 20, minus 30. Like I said, that the scale is actually much, so we are not going to be able to exhaust the space of the graph because the highest value of s I have is 22 and the negative is -6. So we are done with our labeling of graph. So the next thing is to plot the points on the graph. So with the table of value now, so we have to locate each point. When s equals to -4, y equals to 22. So this is -4 for x and this is 20 for y. So we need to count to get our 22. So remember, like the tiny lines in the y-axis is 1 for each and 0.1 for x. So here is 20. 20 against -4. You can see where the line meets here. So the next thing we'll do, we count 21, 22. So this is where the point is going to be. So the next thing is the next point, which is -3 and 9. Here is 10, here is -3, and they meet here. So we now count down because we need 9. So here is 10, so the down one is going to give us 9. Then -2 and 0. So here is -2, here is 0. So that will be on the x-axis. So you can see how I'm putting the points. Okay. Some people make use of a point like this. Okay. I don't actually encourage my students to make their point like this because they might or they are likely to miss the actual point. So I like just a dot. Okay. A dot is a lot better. Then at -1, -1 will give us -5. So we need to count. Here is 0. Here is -1, -2, -3, -4, -5. So what I was doing, I was counting down on y-axis. Remember, here is 0, here is 10. So the middle point of it is going to be -5. Then when s equal to 0 is -6. So s equals to 0 here. Here is 5. Then the next point is -6. Then when s equals to 1, -3. So here is 0, -1, -2, -3 is here. And when s equals to 2, I have 4. So I have to count in positive y direction now. 1, 2, 3, 4. And when s equals to 3, 15. So here is 10, 11, 12, 13, 14, 15. Okay, so we have gotten all our points. So the next step now is to join the point with a curve. So this is where many students, as I'm here now, joining the points with using a curve. So this is where the problem of plotting a graph lies majorly, because some people find it difficult to join these points. Like I said in the introduction, that there are a lot of things people can use to join these points. Some people use a flexible ruler. There's a flexible ruler you can use, and make sure that all the points are in line, then you curve. Then why some people use a broomstick, why some people use uh, things that are very flexible that they can actually bend to give them a curve. Then few other people make use of freehand, though freehand is encouraged, okay, though difficult to learn, but if you practice it a lot, you will definitely get it. Then other people use French curve, okay. French curve, if you are good in using it, you can equally use it. In my own case, I use freehand a lot, and I have mastered the technique of using freehand. Now, what is the technique of using freehand? I will join the point in a very faint line, and my hand have to be inside the curve, not outside, not like this. You don't draw like this. you draw like this. Okay, so when your hand is inside the curve, you can rotate your curve. Okay, you can rotate your curve and plot the line. That's one. Then another thing is that when you are drawing the curve, please make use of a faint line, very faint. Okay, even the kind of faint line I'm going to use first, as you are watching the video, you might not even see it clearly. Okay, now it's going to be very faint, very, very faint, that it will be difficult for one to see. Okay, but why am I making it very faint at first? Because if the curve is not smooth, I don't need to make my graph to be very rough. I will clean it and adjust. So when I have gotten the right curve, I can now make it thick, make it visible. So that's the way I normally use to join my curve. I'll make it faint, very faint at first, so that I can be able to easily adjust any error. Okay. Then after that, I can now trace it back and make it very thick. So that's the way I'm going to plot this graph now. So let me join my curve. You can see my hand inside the curve. So I will go like this, very faint, not minding any form of error. Okay, so I have done that. I don't know whether you can be able to see it from the video, but if you notice, there are a lot of places that the curve is not smooth. So I'm going to adjust it before I erase the one that is not okay. Okay, so I'm just trying to. Okay, so I make use of my eraser to clean some parts. You can see that since I do not make it thick, if I clean any point, it's not going to be so obvious that there was a mistake there. Okay, so I think I've gotten my smooth curve. So you can see the way I'm rotating my graph just to, yes. So all those ones that are not good, that was very faint, so I'm erasing them off and making my curve to be thick. So you can see that I've gotten my curve. You can see how smooth it is. Yes, I'm making it to be visible now. Okay, so I've gotten my curve. You can see how my curve is. So that's freehand. So I've learned how to use freehand to join my curve. So yes, so we are done with the curve. The next thing now is, where is the curve? Where is it cutting the x-axis or touching the s-axis? That is the solution of our graph. So we need to find a value. This is our s-axis. So we need to find a value at this point. That, let's call it our x1. And another part that it cut the s-axis is at this point. So that is our x2. So we need to find the value of our s1. So our s1 is -2. You can see that is -2. So we can say that our x1 equals to -2. Then our x2, we need to count. Remember, the tiny lines in the x-axis is 0.1. So if here is minus, if here is 1, here is 1, and here is 2. So if here is 1, we need to count to this point to now know the actual value of x2. So let's count now. Here is 1, 1.1, 1.2, 1.3, 1.4, between 1.4 and 1.5. So the number between 1.4 and 1.5 can be 1.41, 1.42, 1.43, 1.49 before you now get my 1.5. So like I always say, that graph is not the most accurate method of solving problems, because when you plot a graph, especially if it's if it's manual, I mean using your hand to plot the graph, not using a software, the there will be human error, and there are some values that we cannot actually evaluate using the being a human. Okay, so what I normally do is that anytime my point fall between the line, I will take it as half. Okay, so between 1.4 and 1.5, so I can take it as that S2 is equals to 1.45. So you can see our solution. So you can go to this part to write your answer, because this is your answer for A, including the graph, and the answer for B is S1 equal to minus 2, or S2 equal to 1.45. Okay, so in our next graph, we are going to consider, what of if nothing was given to me and a quadratic equation was given to me, and I was asked to find the solution using graph, just like that, without giving me the graph of, without giving me the scale, without giving me the range. What am I going to do? So that's what we are going to do in our second example. In our example 2, we are asked to use graphical method to find the solution of the equation. Now, in this particular case, no range is given to us, no scale is given to us. So what are we going to do? Okay, so it's a very rare situation, because it's difficult for an examiner to just give you an equation to ask you to solve graphically. Most times, some of the things will be given to you. The range of values of S might be given to you, the scale will be given to you. Sometimes even an incomplete table of values might still be given to you. But let's put ourselves in a difficult situation, in a tight corner, by saying nothing was given to you. So what are we going to do? Okay, so the first thing I will do is to choose a range of value. So I'm going to choose a range of value for myself. Okay, then I will now see the kind of answer, or the kind of values that I obtained for y. That will tell me whether that range that I have chosen is suitable or not. If it is not suitable, I will adjust it. Now, when do we know that the range of value that we have chosen is suitable? If we notice increase and decrease in the value of y, or decrease and increase in the value of y. Okay, so that shows that the range is suitable. But if there is no form of increase and decrease, you can see that in our previous example, you can see that there is this decrease and increase in the value of y. So you can see 22, 9 is decreasing, 0 decreasing, minus 5 decreasing, minus 6 decreasing, then minus 3 is now started to increase, 4, 15. So there must be this dimension, okay? There must be this decreasing, increasing. That shows that yes, that the range that we have chosen is okay. But if there is no form of increasing or decreasing, then we need to adjust our range so that it can give us that increasing and decreasing along the what, the values of y. That is when we have chosen a suitable scale. So let us face our problem now, because that's a kind of, okay. So let's see. let's choose a range, let's say -4 to 3. So let us just choose this range and see the kind of values of y we are going to obtain. So remember, we have to, first of all, like I said in earlier on, we have to make the equation to be equals to y, because if you are asked to solve this equation, there's no way you can plot this on the graph, because graph is a Cartesian plane of x and y. So we have to equate it to y and plot the graph. Then from the graph, you can now be able to find the solution of this equation. So let us equate our problem to y. That means we have x squared plus 3x minus 2 equal to y. Okay, so let's open up our table. So this is our s, this is our y. So we decide to choose this range, hoping that it will give us that increase and decrease, okay, of values of y. So let's have it as -4, -3, -2, -1, 0, 1, 2, 3. Okay, so we need to find the corresponding values of y. So using what I showed in the last example, all we need to do is to fix these values inside this place and get the value of y. So let me show you just with these two, first two. So we have -4 all square, that's for this one, plus 3 into -4 minus 2. So this will give us 16, and this will give us -12, and this will give us -2, which is equals to 2. So we write 2 here. When is -9, we have it as -3, sorry, as s. So we have it as -3 all square plus 3 into -3 minus 2. So that will give us 9 minus 9 minus 2. That will give us -2. So I have -2 here. So here at -2, so I might do the same thing, -2 square plus 3 into -2 and -2. So that will give us, this one will give us 4. This one will give us -6 minus 2. That will give us -4. So here is -4. So in 1, I have -1 square plus 3 into -1 minus 2. That will give us 1 minus 3 minus 2. That will give us -4. So I have -4 here. So if you continue doing that, you fill up the rest. Okay, so when you keep doing this, you can be able to, when you do these things here, or you use your calculator, you get this graph. Now you can see that, yes, we have that decreasing, increasing. Remember, it's not only decreasing, increasing, it can be increasing, decreasing, but in this case is okay. When you have a negative value of your coefficient of s square, is going to be increasing, decreasing. That's the kind of graph of this nature. Okay, but when this is a is positive, you are going to have a graph of this nature. So that's what we are having here. So you can see that the range we have chosen actually gave us that decreasing and increasing, values of y. But this one, I don't think we need this one much, so I'm going to cancel this. So let me redo this. So that will give me, I will say that y equals to s squared plus 3s minus 2 at -4, less than equals to s less than equals to 2. So with that now, I will have that my x values and my y values. So this will give me -4, -3, -2, -1, 1, and what? 2. So with that now, we already have 2 minus 2 minus 4 minus 4 minus 2 and 2. Oh, we missed 0. We missed 0. So here is 0, here is 1, and we now have our 2. 2 is 8. So we have gotten this. Now, when you look at the kind of values we have minus 4 as the lowest value and 8 as the highest value. So I'm trying to get the scale now. So we have minus 4 and the minus 4 and the 8, which is total of about 12 to 13 points. So the question now is that how are we going to accommodate all this? So we can take it as 2, 4, 6, 8. I mean, in our graph, we are looking at how can we take care of this to get up to this in the negative and up to this in the positive. So we can take our scale. So let's write our scale here. So we can write our scale. So remember, in your graph you have a place where you can write your scale. Okay, you have your scale here and you write the graph you are plotting here, which is in our case we have s squared plus 3s minus 2. So the scale we are going to have now is going to give us on s axis. Like I always say, s axis, there's not always a problem. Most time is always 2 cm to represent 1 unit. Remember, that means each tiny line is 0.5. Oh, 0.1. Each tiny line. So on the scale of x, we have 2 cm represent 1 unit. So that makes our tiny line to be 0.1. Then on the y-axis, so from what we are seeing, we can take 2 cm to represent 2 units. I would have said 1 unit, but if you are doing 1 unit, by the time you have your minus 4, which is 4 lines, 0, which is 5, plus 8, which is 13. So I don't know whether we can get up to 13 lines. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the whole line is 13. So that will not be admissible. So it's better we take it as 2, 4, 6, 8, 10. Now, if we have 2 cm to represent 2 units, so it simply means that 0.2 is the value of each of the tiny lines, okay, because we might need it. Now let us come to our graph. So we can see that we have more positive than negative, though it will not really affect much on this graph because we just have 8 and we are taking 2 cm to represent 2 units. So let's rule our line. So using the scale, I have a scale of 2 cm to 2 cm to 1 unit on s axis. So here is going to be 1, 2, 3. So here is going to be minus 1, minus 2, minus 3, minus 4, minus 5. Okay, of course, here is 0 for both s and y axis. Now on y axis, 2 cm represent 2 units. So here is 2, here is 4, here is 6, here is 8, here is 10. Then I have to also go for negative 2, negative 4, negative 6. Okay, so I'm done labeling my graph. So the next thing now is to plot the point. So let us get this point. So when s equals to minus 4, y equals to 2. So here is minus 4, here is 2. So that's our point here. When s equals to minus 3, we have minus 2. So here is minus 3, here is minus 2. We have our point here. When s equals to minus 2, y equals to minus 4, which is at this point. When s equals to minus 1, y equals to minus 4, which is at this point. Then when s equals to 0, y equals to 2, which is at this point, when s equals to 1, y equals to 2, which is at this point, and y equals to 2, y equals to 8, which is at this point. Okay, so you can see the point is actually going to give us curve. Now, I want to say something, especially because of these 2 points here. Because of these 2 points here, some students find this, they are fond of this. When you have, let's say you have a point like this and you are trying to get a curve, some students, you see them coming like this, go straight and go up. That is very wrong, because for you to go straight here means that you are no longer plotting a curve. So this is supposed to go this way, supposed to go this way, you know, give that curve. Okay, so that's what we are going to do here. Some people, you will see that they will go and plot, they will go and join this with a straight line. No, it has to be curvy. Okay, so let us join our points now. So like I said before, my hand inside the curve, so I take it very faint, try to connect all the points. Okay, so I have done the faint one, very faint line. So the next thing I'm going to do now is to do little adjustment here and there. Okay, I can see a little error here. So all right, I think our curve here is a little bit too much. So let me adjust that. Not smooth enough. So, okay, so I think I've got my curve. So I'm not trying to trace it to be thicker so that it can be visible. Okay, so you can see our curve. So you can see our curve. Okay, very smooth. Now the next thing to do is to find the solution of the curve. So which is at this point and at this point. So we need to find the value of here and the value of here. So let me write here. So our x1 equal to, so we have it here also at the middle there. So we can't remember the tiny line on x axis is 0.1. So here is minus 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, between 3.6 and 3.7. So I can take it as minus 3.65. Then this one is exactly on the line. So this is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So our x2 equals to 0.6. Remember, graph, like I said before, graph is not the most accurate method of solving problems, especially a graph that you are plotting with your hand, because there tends to be a little error here and there due to that's error due to human error. Okay, I think that's what they call it, human error. So that's how to plot your graph. Then, you know, there are a lot of things that you can be asked on this graph. So I'm going to list some of them, though I'm going to make a video on most of those things. So I'm going to list out what you can be asked from this graph. You can be asked to find the line equation for line of symmetry, equation for line of symmetry. You can be asked to find the minimum or maximum value of y. You can be asked to do that. You can be asked you can be asked to find the gradient or find the value of s at a given point or value of y at a given point. So you can be asked to find x at a given point of y, or y at a given point of s. So you can also be asked to find uh, the gradient at a given point. Also, we can also use the graph to solve simultaneous equation of one linear, one quadratic equation. So you can also be asked to use this graph to solve problem on simultaneous equation, which is one linear, one quadratic. There are a lot of other things we can use the graph of this quadratic equation to do. So all you need to do is to learn how to make use of this quadratic equation. So the first thing is to know how to plot the equation. So when you know how to plot the equation, all these other ones is going to, be very easy for you to do. Okay, so we are going to make video on most of this, how to find line of symmetry, minimum or maximum value of y, finding s value at a given point of y. In fact, we are 1, 2, 3. These three, we can use one graph to show it. Even this one, we can use just one graph to show all this. Okay, though if we try to use one graph to show all this, because no examiner will ask you all this in one graph, because it's going to make the graph to be very messy. So we can just ask you a few of them. There are other ones, the other things we can use this graph for. So in our next video on this graph, on quadratic graph, we are going to use it to solve different problems. Okay, we can use we just need two examples to show all this. Okay, so thank you so much for your time, and I also want to, appeal to you. uh Please share our videos to your friends, to people in your social cycle. Okay, and they subscribe to our channel if you are watching this. Okay, thank you so much. See you in the next video.